That's going to be quiet.
I'm doing good.
Okay, so today's lesson we're going to be doing the reactions of the group 1 metals. So in group 1 we've got hydrogen. That's not a metal, so we're not going to be reacting that. But we'll be looking at lithium, which is over here, and stored in an oil so it doesn't react with the oxygen and air. Next down we have Na, and Na is sodium. Here's sodium. It's also stored in an oil. Can't see it, but it's there. And this one, next one down, is K, which is potassium. Okay, so we're specifically looking at how these metals react with water. And so obviously if these things are stored in an open container, they're just react quickly. We know that metals react with oxygen anyway. That's what happens when something rusts. That happens fairly slowly. If I let these things just stand in the air for too long, they'll rust within a few seconds. So that's why these things have to be carefully stored. Alright, we're going to start with lithium, which is over here. And we're going to be using very small amounts first. Well, yeah, in general, these metals are quite expensive, so we can't waste them. And the first thing you'll notice is that there's a few properties that are very different about these kinds of metals compared to what you might have seen before.
So,
Yeah.
what's that tool that you use in Crombie?
Yeah, these are tongs. That's fine, that's the chemical name. Alright, so I'm going to cut through this metal. It's going to require, if I was to cut through steel, probably wouldn't be able to use one of these. But lithium's a bit different. It's going to take a little piece. And I must be a little bit careful that I don't cause it to explode. Alright, there you go. You can see it. If you come close and bring the camera a bit closer for now. Okay, so already within a few seconds you see this thing's gone a bit darker. It was shiny when I took it out. I'm just going to scrape off some of the oxidation layer. This is already rust is forming within a few seconds. That's going to prevent my metal from reacting, so better get rid of that. Okay, this happens faster than I can even scrape it off. Okay, we're not expecting this to be hugely reactive. This is the first one on our list. Alright. Yeah, well, it's not really in contact. If you look closely, you have to bring the camera a bit closer. You can see some fizzing.
You still can see it moving around.
It's gonna grow teeth.
Oh, nice.
It's alive.
There we go.
Oh, sick. It's flying around.
Oh, nice.
Gonna bite you. Gonna eat Chris.
Any idea what that gas could be that's being given off?
Hydrogen.
It is quite correct. It's hydrogen that's being given off.
Yeah, but it's Chris gas.
Can't see the molecule.
Okay, guys, stand back a bit.
I think you want to see the song.
Okay, guys, can you stand back a bit?
Stand back a bit, guys.
Come on, get back. Nothing to see here.
Okay. So that was lithium. A few interesting things about that. It was a soft metal and oxidized very quickly. You saw that, well, you might not have been able to see, but as soon as I scraped off that oxidation layer, it immediately went brown or rusted again within a few seconds. So these things are a lot more reactive than a piece of steel or iron. Okay.
What's the white stuff around it?
The white stuff around it. Okay, this is actually reacting with some part of the oil inside here. So yeah, that's what the white stuff surrounding the metal is.
What happens if you cut it incorrectly?
It's probably nothing. It's not that sensitive. This isn't so sensitive that it would spontaneously combust. Phosphorus, on the other hand, that has to be cut underwater because it's so reactive. Okay, the next one down, we're looking at sodium, and there's some sodium metal here.
The name of it.
Yeah.
That's not universal.
The real reveal.
We're gonna talk.
Yeah, so what you're seeing is the outside layer that's reacting with some of the storage but it's not cooked. Alright, I'm going to cut this. Starting with a very small piece. Yeah, this is expensive, they're all expensive. Okay, so here we go. Piece of our sodium metal, also quite easy to cut through. Again, scraping off the oxidation layer here, you can see it's still shiny. The shininess is a property of metal, so remember we've got those delocalized electrons which are able to reflect light. Alright, this is our piece of sodium. Let's see what happens.
Come on, don't stick up.
Oh, nice. Yo, that thing is it's like a paintball, is it? Passing, bro. They're like a bullet. Yo, check it out. Sir, and you can put like 5, so they're like samples or... Oh, yeah.
Okay, just be a little bit careful. These things can split a little bit. There is certain tension of things. Direction it's moving in is completely random. Okay, no, we can't waste this stuff. Also, putting a whole piece, I will put a slightly bigger piece in.
Next time you can do that, but you can do it for your time. But I can do it.
Yeah. Okay.
Don't cut your tongues.
Okay, so just this can split a little bit, so don't stand too close.
Wow, nice.
Okay, so what happened there? Why did that thing suddenly catch alight?
Sure.
Oxygen and hydrogen, because it was the hydrogen gas that was being given off, reacted with the oxygen in the air. We had enough heat, so that was an exothermic reaction, and suddenly created a explosion. So, okay, moving on to the next one. Next one I'm going to just cover up so that we don't get any explosive pieces. We're not necessarily guaranteed an explosion with potassium.
Nice.
I'll probably break that container and it should be
Oh, nice.
okay.
How would you make a bomb?
It's very soft, easily cut.
Great cheese. Great cheese.
Okay.
Yeah, do that.
That's class.
Please do not charge it down.
There is enough oxygen in there to create that flame.
Second try again. Bigger piece.
Yeah. Yeah, we'll have a slightly bigger piece. I don't want to get too carried away with it.
Nice.
So what metal are we dealing with?
Nice.
Potassium. So hopefully you can see as we go down the periodic table, we're getting more and more reactive.
So can you buy the metals out of life?
No.
Wait.
Unfortunately, that isn't stable in nature. It has to be manufactured in a special...
How about chromium?
Yeah, it's like the same.
It's a little bit bigger.
Aluminium.
Nice.
Alright, that's pretty cool. So as soon as I put a little bit more oxygen in there, we got a bit of an explosion. I don't know how easy that now.
Nice.
That is so cool. Okay.
One more. One more.
Okay, that's enough and I can stop the video.